Hi, Scott. I figured it's probably easier to talk through this and kind of show you what I've been working on rather than try to type it out in an email. So here kind of goes. We've got here the results for hypothesis H1A. So that's looking at the multiple choice test with 5 groups: control, relevant texting, Twitter relevant, irrelevant texting, and irrelevant Twitter. Most of this is just pulling from the test we'd already done. I had left this one out originally because it's this one's irrelevant texting versus irrelevant Twitter. That was just the contrast, and it's because it limited me to running 10 contrasts at a time, and I think this one was just left out. It was non-significant, so it doesn't impact our results. But here's the way I would kind of look at this. We know that the overall linear trend is statistically significant. The deviation is non-significant. That's in the write-up. I put in the actual p-values. If we were to reduce to 0.01, the linear trend would still be significant. In this case, control versus irrelevant texting would be non-significant. Relevant texting versus Twitter relevant would be non-significant. Relevant texting versus irrelevant texting, and then relevant texting versus Twitter irrelevant would be statistically significant. What I did over here on the right, though, and I'm just going to scroll over slightly, is when I was looking in my EDRE textbook, it was talking about basically the procedure that we ran in limiting the risk of type 1 error by doing the 2-key HSD. While we put that in there, I don't think it actually did the 2-key test, at least using the data that we have. So what I did was computed it by hand to calculate, let me see, a Q ratio instead of a T ratio. So according to what I've got in the textbook, you can do this to limit type 1 error. And I'm quoting here, essentially the 2-key HSD test uses exactly the same formula as a T ratio, but the resulting test ratio is labeled Q rather than T to remind the user that it should be evaluated using a different sampling distribution. I've got the distribution, the table in the back of the book, and I've got these values here. So on the right, where we've got 5 groups, Q value 0.05, Q value 0.01, that would be what the critical Q value would be if we were looking for 0.05 level or the 0.01 level in terms of statistical significance. So the formula for that is the mean of group 1 minus the mean of group 2. I've got those values here. That's the numerator position, and then in the denominator position, it's the square root of the mean squared within divided by n. What I'm guessing it means for n is if you add up the two n's of the groups that you're using, what would be that overall n for the two groups that you're pulling from. So that's what I've got in this column, which is just adding up the n of group 1 and the n of group 2. So numerator position, mean of group 1 minus mean of group 2, so that's what I've got here calculated out. Denominator position, square root of mean squared within, I pulled that from the linear ANOVA, and then also divided that by the n that we're using. So that computes this critical Q value. So I've got that here. Red means we didn't hit the cutoff, green means we did hit the cutoff. So the way that we could look at this is this Q value for, and I'm just going to scroll over real quick, so that's looking at control versus irrelevant texting. I've got that these highlighted in yellow because those are the ones that we report as being statistically significant. So that's in our original write-up as it is right now. And if we look at that real quick, all of those yellow ones match up with the green ones. So what I think SPSS did, or at least what we've got doing here that we might include in the write-up, is that it did use the Q value statistic, which helps us to protect against type 1 error by using a more stringent value, a more stringent critical value to use in order to declare that a contrast or that the post hoc test is statistically significant. So in our case, with our post hoc tests, at least according, if I did this correctly, we're hitting that 0.01 critical value in each of these. So the critical value would be 4.6. We hit that on each of them, so this one 4.65 is higher than 4.6, and we do hit that at the 0.05 level. So if I'm reading this correctly, it looks like the contrasts we're reporting as statistically significant are indeed statistically significant at a more stringent critical value for what we would declare as being statistically significant. What I'm going to do is do that for H2A, basically replicate that. It's just a matter of calling through the outputs to pull in the right information, but we've got that. What I do have here for 1, 2, 3, and 4, if we were just doing the differences on that line, so if we're doing the bare minimum comparison, so this is kind of replicating what we have. So to talk through that, when we posited the linear relationship of control group would do best, followed by relevant texting, that's what this comparison 1 is doing. So then we've got, for comparison 2, relevant texting versus Twitter relevant, and then Twitter relevant versus irrelevant texting, and then irrelevant texting versus irrelevant Twitter. That would be the bare minimum comparisons we would do. So that would be the bare minimum we could get away with, and in almost all cases except for one of them, those were non-significant. So if we were to go that route, we really wouldn't have anything. That nuanced comparison between all of them, basically doing all of the comparisons, is it looks like what we kind of need to do, but I think we've got the evidence that we were protecting against type 1 error by using this. I'll do this for H2A and get back to you with just kind of an email, but that's what I'm thinking for the time being. Feel free to give me a call or a text if need be, or an email, and we'll hopefully talk later about it.